take a look at the equation of a circle. So we're going to kind of jump into the coordinate plane for a little bit and look at actually the equation based on an x and y situation. First of all, a circle, as you know, is defined as the locus or the set of all the points that are equidistant from a given point. So the idea of how that circle is formed is that it is the same distance, all of those points that are exactly the same distance away. Now, as soon as you hear that idea of equidistant and distance away, we can use a nice little relationship to come up with the equation of the circle. And that situation, of course, is you can either use the distance formula or the Pythagorean theorem. And the idea is that there is this nice little right triangle that's in here, and this will allow us to do a little bit of calculating. We will need at some stage the run of this little triangle as well as the rise. And if we were to set this up using the Pythagorean theorem, it would look a little bit like this, r being the radius. And if you were to calculate it, it would be the run squared plus the rise squared equals the radius squared. Now in our case, that rise and that run, the run is just this point here, which has an x-coordinate minus the 0 from the origin. And then the rise would have that y-coordinate here minus that, again, that 0 value. And in this case, things are quite simple, or they get simplified greatly. This guy here that we actually began with, this is the generic or most basic, or if you want to think of it as the parent form of a circle. This is the equation of a circle that is centered at 0, 0 and has a radius of r. So this equation right here will represent anybody centered at 0, 0 and with any radius. So if I wrote x squared plus y squared equals 100, what that would mean is it's centered at 0 and 0 and its radius is 10. Do you notice something happened there? You might have went, hey, wait, how come we didn't write 100? Well, guess what? See how this says r squared? Don't forget then that when you go after finding r, you will take the square root of that number. But this represents kind of a very basic circle centered at 0, 0 with a radius of r. Now, truth be told, most circles aren't going to be centered at r. We're going to place our center here at, we'll just call it h comma k, just two variables, an x and a y. And what we're going to do is use that same relationship of the Pythagorean theorem and that whole idea of rise and run to derive a more general format of this. So the run of this is right here, which would be the x value that we've added minus the initial h value. So it's x minus h squared. That would be our run. And then our rise would be y minus k squared. That would be our rise calculation equals r squared. Now this, again, let's just make sure you understand where these things came from. So again, centered at h and k. So we would take our x minus our h would give us this, and our y minus our k would give us this, and that would calculate it out. Now this certainly doesn't look pretty, but this actually is the more powerful or more general format of the equation of a circle, and it tells us a lot of things. Let me show you how quick and easy that this is in terms of telling us things. Here's an example of what it might look like. This tells me that this would be a circle that would have a center of 3 and negative 5 and a radius of 6. Now you might say, wait, slow down, what happened there? Well, first of all, notice that the notation is x minus h. So if it's minus 3, That means the value that went in there was a positive value. It didn't change the negative, did it? Because that's the general form of it. So that -3 really means we put in a 3. The fact that this is positive meant that a -5 went in there to make it +5. And then always remember, and this is a little trick, always remember that the radius is the square root of that number. So just for the sake of another example, x plus 7 all squared plus y squared equals, let's say, 7. Well, what do we know from here? Let's take a quick look. So we learn a little bit here, a little bit here, and a little bit here. What we learn is that this would be a center at 7, -7, and 0, and that the radius is the square root of 7. Wait a minute! Explain. Yes, I will. So here, again, why is this a -7? Because in the original case, if you put in a -7, it would become positive. Why is this 0? Well, you'll notice that there was no change to that, no right or left movement of that. And so we have our 0. And then the square root of 7 happens to be the square root of 7. Here it was a nice square root, but here we get a square root 7, that's all. So while it looks a little bulky, these really help us out in that the values that go in here and here will represent our center, and the square root of whatever number is here will give us r every time. So let's try a couple quick ones. So our center will be found with these numbers. Our radius will be used here. So our center would be at 2 and -5, and our radius would be 10. Try it again. We're going to find our center here and here. We'll find our radius hiding in here. And so our center would be at 8 and 0, and our radius would be 5. We will find our center here and here, and our radius hiding here. And so this would be a -3 and a +1 with a radius of the square root of 14. So the only thing, again, you just got to get used to that being kind of a reverse of what you would expect, and always remember to take the square root of those values. The reverse process is not hard at all. If we are centered at 0, 0, that means x squared plus y squared equals 16. Remember, square that number. Here it would be x minus 3 squared plus y minus 7 squared equals 100. Switch up a color here. Let's try this one. This would be x plus 3 squared, y minus 5 squared. Now this says the diameter is 6. That means our radius is 3, and when you square 3 you get 9. Here we get x plus 5 squared, y plus 1 squared equals 11. Why 11? Well, r equals the square root of 11, so when you square that, you just get good old-fashioned 11. Once again, quickly, let's just go from what we know. Minus 3 will be the x, 4 will be the y, our radius will be a 4. Here, it would be 0 and -8, and 2 would be our radius, because that's the square root of this number. 2 and 1 will be our x and y, and 10 will be our radius. Finally, 1 and 0, and the square root of 17. See how once you get the pattern, these are quite easy. The last 3 will cause us a little more work, not too much though. So they want the equation of the circle, and they give us a center, and they don't give us the radius, is what they don't give us. So we need to find the radius, which is just the distance between a point on the circle and the center. So in this case, that would be 3 minus 0 squared, and it would be 4 minus 0 squared. We would get a value of 3 squared is 9, 4 squared is 16. We'd get the square root of 25, or in other words, 5. So now we're ready to roll, aren't we? Because we know our center is at 0, 0. So there's our 0, 0 center. and we got an r value of 5, so this would represent the equation of this guy. So the only thing we had to do here that was a little bit different is they didn't give us r. We had to find the distance between these, so I just used my distance formula and calculated the distance to be 5. Similar situation, we have the center but no r. So we are going to quickly calculate r. r would be the distance from the difference in the x values, the difference in the y values, all squared, and we get 2 squared plus 2 squared, 4 plus 4, and I get the square root of 8. Now I'm actually going to leave that as my r. Maybe you'd say, I want the decimal. I'll show you why you want to leave that. So now we go back to the original guy. Here is our center. So it would be x minus 3 squared plus y minus 7 squared equals 8. See why I left that as the square root of 8? Because when you square that, you just get a beautiful little number right there. Let's do one last one. The last one's kind of unique and kind of fun, actually. So they give you 2 points, an A and a B. And neither of those are your center. Actually, what are they? Are the endpoints of your diameter. Now what that means is you have a circle and then you have those 2 points. So we need the middle, don't we? And if you remember, we have a midpoint formula. And the midpoint formula just says add your x values together and divide by 2. Add your other values together and divide by 2. We get 6 halves, we get 10 halves, and so we get 3, 5. Now we're ready to start, right? We have finally our center at 3 and 5. So let's do what we've done before. First, we're also missing the radius, aren't we? Now that we have that, let's calculate our radius. Our radius is the distance from one of the points to the center, so I'll do the 15 minus the 3 and the 10 minus the 5. I'll just use, and again I'm using this point. I could use either point, but I want to use the center to one of the points. So 15 minus 3, 10 minus 5. This gives me 12 squared plus minus 5 squared. This gives me 144 plus 25, which is the square root of 169, which is 13. So we're ready to write this out now. Let's do a quick color change. Here we go. So it would be x minus 3 squared plus y minus 5 squared equals 169. Let's just do a quick review of each of these things. We were given the endpoints of a diameter, which meant that we had to find the middle of that. So I used the midpoint formula to find the middle, or known as our center. We were also missing the radius, so I took one of the points at the end of the diameter and calculated its distance to the center and got 13. Then I was ready for x minus 3 squared plus y minus 5 squared equals 13 squared. Good luck on this, guys.